Hey.
Hey, I'm sorry.
Yeah.
My internet decided to shut down for a moment right at 5:59.
Okay.
Yeah. So there's nobody else for that?
I don't think so.
Mm-hmm. Okay. Mm-hmm. Just,
Yeah, well, I guess nothing much from me. You can continue unless somebody else joins. It's just 6
Okay.
actually.
Yeah. So I'm just trying to pick up back the stuffs that we were at.
Mhm.
So yeah. Yeah, this is the one I had put it up. Okay. So I don't know if people had a look at the notebook and did something with it. I don't know.
I don't know for now. For some reason, is something happening in India as such? Because nobody joined me. Tuesday session, nobody came, Power Electronics. So I just cancelled it.
Oh, is it? Okay.
Yeah, I don't know.
I don't know. I don't know. I have no idea because there is some internet problems in India. No, I don't think so. I didn't see anything in today news did not say anything. Only thing maybe is that some parts of the country they are lifting the lockdown. Like Tamil Nadu, they are lifting the lockdown since yesterday, I think. So yeah, there is nothing really. Otherwise, I don't think anything is happening. It's probably a curious set of multiple coincidences.
Right. Okay.
Okay. So
I found out before that about that. I don't know. Did you have a look at that video game dataset? That video about the index slice.
Yes. So I think I did that. I'm just probably it's been a while. I will just have because I did that immediately, almost immediately, or within a day or two. So I listened to heard the few videos. I think one was on using lock because lock was what I was able to make sense of easily, and then multi-indexing through lock was what you had done.
Yeah, exactly.
Yeah. So I think I did just to see whether I did that myself. I have the code here or not. I'll just check. Because I then again moved to another Jupyter notebook because I was getting too many things and then I was not able to track it. So, but anyway, I think it's still there. Let's check. Yeah, and then also this IDX that you had used.
Yeah. Well, IDX is actually its index slice, which is named as a variable.
Yeah, I mean index slice. I'm sorry.
Yeah, exactly.
I'm sorry. Index slice. So I was able to do, like, for instance, I will show you the screen. Okay. So I think I did something like this. Do you see the screen?
Okay. So IDX has already been made as pd.index slice. Okay.
Yeah. So this is the index slice.
Right.
And then I wanted to say, for instance, for the resort hotel, I also included for this new data, I also included lead time. So because it's another data for which you can calculate, say, the mean or some other. It's a numerical value. It's not a categorical value. So, or rather, it is not. It's sort of a categorical, but it's integer at least. So I was able to do that. So you see that I was able to get. Of course, it's the arrival date and month is still not arranged, but that's because it's an index. So for the multi-index, the other, so you have the actual data set is something like this. So we were trying to split it into multiple parts using multi-indexing. So I had looked up and I saw that this will, for example, do that.
Yeah.
And I was trying a few things. So one, perhaps I started trying a few other things because there's like I was looking at what sort of I wanted to answer or say build a model to a proper model, so to speak, or whatever. So for instance, I wanted to say that I want to create a recommendation system that will given a hotel type, stays in weekend, night stays in weekdays, number of adults and children, babies or whatever, and also given the average daily spending somebody wants to do. Can you give me a range which 2 possible months or 4 possible weeks, depending upon what they want to do. It's a sort of a prediction system, recommendation system there. It's not actually a recommender system, but yeah, sort of recommendation system that will tell you that. So essentially, it's building a machine learning model that can do this such that predicts something, and then you pick the top least cost. Closest average spending, closest one that they say which 4 weeks we can suggest, or once even. I was trying to see. So the question I have is this. So for doing such things, so we need to, for instance, do an analysis of saying that how much. Given a variable, given a variable here like a hotel type or stays during the weekend and all that, or say let's say number of days stay. How do I do some analysis saying that how much of this is useful, whether this factor is useful in predicting, for instance, when to travel. Like for instance, number of stays during the weekend and weekdays, total number of days. Does it impact, say, the average spending such that we can say I will be able to predict the minimum, the time when you should travel.
Okay, let me get this straight. Now, we have the hotel type, which is basically a resort hotel or this thing. So you have that option whether you want to go to a city or you want to go to like a rural place.
Yeah.
Second is the duration for which you want to stay, and you're willing to split it up into weekends and weekdays.
Yes.
You have the total group of people that are traveling, and you have your total budget. Now, this I'm assuming is your max budget. You want to stay within that.
Yeah, we can do that. Yes.
Now, what that means is this basically becomes like a kind of, that is, the function is of, well, it would also know the function of what you want to know is what is the lead time, right? What is the lead time?
That which we should book.
Right. Now, trying to formulate this problem, we can say one is that the output of average daily spending, right, should be less than whatever it is that we have done. So it is a less than equal to relationship. And it is a function of, all the other factors, including the lead time. Now, that is usually what is happening, I think, right? Because so far that is a simpler thing that we do.
Yeah, or maybe, now I realize that there is an issue. Maybe what we can otherwise add is that we can say the current month or current week that we are in right now. And then it can give a sort of a range over the next few weeks. That if you want to travel over the next, next 52 weeks, So, what exactly are you likely to? I mean, where should you go if you have a particular limit on the money that you want to spend?
Now, here, I don't think there's a geographic breakdown that much, right? But let's suppose, for example, a person says he wants to go for a countryside trip, right?
Yeah.
Now, what we need to do is we need to formulate a function of all these things. That is the max average daily spending, total number of people, total stay, and the type of the hotel. Has to be, we can say, now what kind of relationship it will be, because you want to know that within such a lead time, that is, let's say you say that okay, now this is about booking or this is just the time to go? What would it be? You want to know how soon you need to book, or you just want to know which is the best time to travel?
Yeah, so it'll be, so I think from a person's who wants to travel, it's just you suggest them when you should travel. That's
okay.
Like, because that's a lot easier than saying that, look, okay, if you want to travel at that time, you should book this time, because then it becomes a two-step process. I mean, which is fine, but I think I want a single step process, and that's why I'm trying to reduce the problem. In fact, what I changed it was, if you look at it, I went down to saying, for instance, or rather, they give me, the person says that, okay, hotel type, stay, everything is given, and all that the algorithm will tell is that average cost one would end up spending if you are going to do these things. This actually would be quite straightforward. This is, I think, would be the simplest machine learning algorithm. You just put all these factors, put the data in the right way, whatever form, and so and then it should be fine. The only problem is, I mean, I still don't know, is that because there are I looked at, and there is about 30 to 35% of the whole booking has been cancelled, which means out of the 120,000 data points we have, about 45,000 data points are cancelled. So the question in this case would be, of course, should we take up all of them or separately? And or, for instance, if I want to build a model like this, the person says the hotel type, should I build a model which would contain for both hotel types, or should I have two different models? And depending upon what that person chooses, and you choose one of the models, because, for instance, it may happen that the variation in the hotel type in resort hotel is quite high, the cost of variation, whereas in the city hotel is a lot lesser. Probably it varies based on other factors, but the hotel type, it varies less due to the time of the year. So would it get, I mean, I don't know if it would get averaged out. The variation in resort hotel data would get averaged out, because the resort city hotel, which has more numbers in terms of the booking, and because the number of booking in resort hotel is about 60 to 70%.
Okay.
So that is, those are the constraints that are there. But do you think this would be like the simplest case where I just don't need to do anything except for putting the data in the right way, and then calculate the average cost, which means it will essentially should give whatever we see as the average cost, just that right now we can probably say split some data, take some data away, and then say that data is a test data, validation data, whatever we can do. But the pattern right now that we see should be what the machine learning algorithm should predict.
Yeah, no, I think that's fine. For example, you can always say that there's two ways. One is, if you want to travel at a particular time, is it possible to predict the average daily spending? Yeah. Right. That's one. Second is, if we put a limit on the average daily spending, then what is the range or what times of the year could we potentially travel and stay within that budget? That is the thing. So instead, one, we can say we can put a maximum limit on the average daily spending, or we can say this is the range of average daily spending. So what should be a good time when you can go for this? Like in that case, of course, the recommender system also has to choose the best possible. So we also have to rank places according to their quality. So you see, therefore, according to ranking of quality, when can you get the best possible rank at the best possible price? That's what it boils down to. So, looking at this, we have opened several questions. The first question, one question is that how are resort hotels differing from city hotels? Right. Okay. So one is, like, for example, if you were to segregate hotels into two types, what is the difference? For example, one, average daily spending. Two, things like cancellation, lead time of booking, like do people book in one case, do people book well in advance, the other case, people book at the last minute, things like that. Yeah. Then the next thing which you're saying is that if we look at the booking, like for example, there is average daily spending, is there a way for us to know what is the booking charge? So for example, this is the booking charge versus this is the average daily spending. So there's a difference. So the booking is just for the room, or maybe just a breakfast included. Whereas the average daily spend includes everything else. Meals, all the other aspects. So now, if we were to say that their difference is insignificant, or usually it should be in a hotel, but even if we find that in some cases it isn't significant, then even if the trip is cancelled, it wouldn't make a difference. So even if the trip is cancelled, you would say that the person would not have spent a much greater amount than you would have spent just in booking the room itself. Okay. So in terms of exploratory data analysis, we could do all this. Yeah. So we could list out what all we want to do, and we could try, because what I would say is, before you handle a recommender system, I would suggest that try to get a little comfortable with Pandas data frames. Yeah. And also in things like querying and things like that. Yeah. So things like, how do you...
Or the plotting the data.
Plotting data, yeah, but what is most important is in actually manipulating your data into a format with which you can feed it to a machine learning model. So,
yes.
Usually what people say is that almost 70% of the job actually in machine learning is actually altering your data and fitting it into such a format.
Yeah, that's true. And especially today with all the, like, I was looking at this scikit-learn different machine learning tools. I mean, even if you don't know anything, all that you need to know is, give X, Y, and then perhaps some things, and that's it. You have those steps, split the data into these forms, and for that also you have tools. So essentially, there is very little that you have to worry about. Though I see that for temporal time series data, things are not that straightforward as compared to other types of tabular data. There is something that you have to do a little more with time series data, but otherwise everything is like set in stone once you have everything about the data ready, which I think, as I said, is about 70% of the project.
Yeah. So
So perhaps we will write down, because I had once written down something. Maybe we can revisit, but so we can try to analyze whatever data we have to answer some questions.
Yeah.
Okay. So, for instance, we can, let's say, because there are, let me just put. It's an easy thing to see. Okay. So let's say because I think for instance, do babies account for any um, cost, or for instance, or is it only adults and children contribute to the ADR? Because we don't know. Because for instance, I can easily drop the baby's column.
Yeah.
In essentially, if otherwise right now I don't know about it, and then because there is a room type, reserved room type and assigned room type. How much does the room type affect the cost?
Yeah. Yeah.
And for instance, does the change of reserved to assigned room is responsible? Okay, it's not really useful. Anyway, because if this does happen, that is somebody's reserved room is not same as the assigned room, is there a cost reduction?
Yeah, you can know that is worth it. You can have a look at it.
Yeah,
is there a difference in the cost?
A nice question we can try, but yeah. So if does the change of reserved room to assigned room leads to cost reduction, cost saving? It's like for the same assigned room.
Right.
So it's something like upgrade in airplanes, going from economy to first class order. So and then so I mean, one of the things I was earlier talking about for with respect to the hotel people, like hotel guys want to know. So which people from which country spend the most?
Yeah. Okay.
Spend the highest over. Because there are different countries, and this one is in Portugal. So I looked at some more details. Yeah, this is like a resort in the south Portugal, in Algarve, I think, and then one in Lisbon. The city hotel is in Lisbon. So yeah, so people from which country spend the highest, and then so I mean, what sort of complex things that you think we can ask? Because I'm writing something which are more from an intuitive perspective, but from the perspective of the difficulty in getting some information, what do you think would be interesting? I mean, what do you think would be interesting to try? Because in Python, we have to try those things.
So let's look at this. Let's say, for example, look at the columns. There is cancel, lead time, arrival date year, date month, arrival date week number, stay in weekend nights, stay in weeknights. So this is also something which we thought we should look into. Stay in weekend nights, stay in weekday nights. Adults, children, babies, meal, country, market segment, distributed channel, is repeated guest, right? So now this is another thing which you want to look at, is that how are hotels handling their previous bookings? So for example, is it, for example, how many guests are actually coming back to the same hotel? And when they do come back to the same hotel, are they spending more? Are they spending less? Or what actually happens?
Yeah. Okay.
Because this in terms of a data science problem, this helps the marketing of hotels, because they know if somebody has come and leaves a good reference or at least seems happy, you can actually target the person to come back again.
Yeah. Okay. Country. Okay. Expenditure. Number of days. So perhaps we can look at these things. The characteristics of repeat customers.
And most important is the daily spending. That is the average daily spending, whatever that is.
Yeah.
Yeah, I mean, that is expenditure. Okay.
I'm sorry?
That is already captured in expenditure. So that's okay.
Yeah. That's what area. Yeah.
Area. So
and compared to non-repeat customers.
Right. Yeah.
So how do they fare?
Yeah.
Perhaps they spend more or whatever.
So this is one. The second is, if you look at booking changes. The next question is, when booking changes happens, does this lead to an upgrade, a downgrade, a cancellation? What actually happens, right? So this helps. Why? Because if booking changes actually result in upgrades most of the times, then it actually makes sense for a hotel to try to find out who the person is and try to chase him down. So if somebody is like trying to make a booking change, right? So in that case, you might, and if you see most often that people end up spending more when that happens, you can actually have someone call him up and say, okay, do you need help? If you're trying to make a booking change. So like, then try to tell him about options and things like that. If it is totally random, then you could let it go because you don't know. It's not worth having somebody spend the time and actually chase the person.
Yeah. So I have to check what exactly is there in booking changes.
Exactly. So this is the main thing. This is like data exploratory analysis. These questions will kind of help you go there.
Oh yeah. Yeah. Okay. And then. So this lead time, how we can probably analyze something about lead time with respect to some other parts of data. For instance, does it happen that somebody who booked quite early? But I saw that the lead time was quite ridiculously different, like going up to 100, 200 days.
Okay, another thing which you can have a look at is the agent column. So how many of them are actually booking it themselves? How many are coming through an agent?
Okay, yeah.
Because this would mean that if a significant amount of them are coming through the agent, then it actually makes sense for hotels to tie up with agents. Whereas if they are, and again, agent mean, is it a physical agent or is it like a online travel site?
Yeah.
If it's an online travel site, there's not much you can do. Maybe.
Yeah, we have to check that. If you want, I can quickly check that. Okay, to open the dataset.
No, you can just check it out on your own Jupyter notebook. You can just quickly.
Okay,
that's okay. Because it's like here you're through the internet.
Yeah, exactly. Let's check.
So, no, so for example, okay, you want to do the last one first?
Yeah, I mean, okay, yeah.
That's it. Agent. Now.
Okay, so this is like there's something. I don't think we can make sense of
just find out n unique. How many are there? Because it could be that the agents have codes. Just do n unique. No, well, yeah, n unique will give you how many of them are there.
Numbers. 333.
So
So which means it's quite a diverse one.
True, but no.
Okay, so yeah, so
No, value counts actually. Can you just
because there's one guy, a couple of a few of them who are responsible for the majority of booking.
Yeah.
As far as I see.
That's what I'm trying to figure out. Now, if you look,
so you'll have to do greater than something, right?
Yeah, you can do non-just.
Something like this. Okay.
No, what
okay,
did you
still
do?
a lot. Still a lot. Okay, I will say for instance 100.
Yeah.
So I did this. Is there a simpler way to do it? So I say df this one.
That would be the. Unless you see value counts, you can just, if you've already done that, you can just extract the top 5. So you can just say
okay.
colon. Yeah, that's it.
You can do a head.
Yeah, you can do the head 5, head 10.
Okay.
That's it.
That's easy. Yeah, that's a lot easier.
Okay.
So yeah, well, I think if we just do so this is like if you look at the entirety of them compared to so yeah. So this is like 71,000. This one is 100,000. So essentially 70,000 bookings are happening through the top 10 agents.
So now the next question is, are all these through agents only? Looks like.
No, perhaps one or two of them. There is an NAN also.
There is an.
But it is possible that one of the name of one of the agents could be direct booking, because they use there is a lot of anonymization happening.
Okay.
So because this is the same issue with some other parts of the data where they have anonymized it. So for instance, they have room number, room type, and the room type is such that they have given the same name between resort hotel and city hotel, but they are perhaps not the same same rooms.
Okay. So then this doesn't seem something which we can pursue, because if everyone has it, then I was thinking it would be at least maybe a few codes or maybe individual or something, but that's not the case. There are actually agent numbers given to most of them.
Yeah, exactly.
So then in that case, this shows the number 7 really is maybe not worth pursuing right now.
Yeah.
Maybe later, if we do decide, if you would like, say again, just if you do, let's say, just do a df.head and just look at the entire thing. So if you see, if we were, for example, to sort this with or rather group it with respect to the agents, right? So let's say, for example, create another data frame and just pick out of this the hotel type. So no, I mean a list you have to create. So and then let's say
it's more easier for you to see.
Yeah. So we can have hotel, we can have, let's say, ADR, of course. ADR is very important.
Yeah.
Then we can put the agent.
Yeah.
And I'm just thinking if there's anything else we could have.
it's also is cancelled because if a particular agent is prone to being cancelled.
And also is repeated guest. So are they handling old customers? So is repeated guest. I guess this is enough. I guess this is enough for now. So you can just
or at most you can say that sum of the total number of days somebody stayed.
Okay, yeah, we can put that stay in weekend nights, stay in weekday nights.
Because that way, I mean, we can create a single one later, but because that will tell whether someone is agents are mostly getting short-term booking. Okay. So now we want to group it based on the agents.
By the agent, yeah. So you know how to do like this. Basically, you can actually create another one. So this is like a DF agent. Again, a DF agent is equal. And you can say, what you can do is you can say initially just do mean and then we'll see later. Because we might have to do things like count and other things, but for now we just do a mean.
Yeah, probably we'll have to do a function and then apply.
Yeah.
Okay, let's see.
Okay, so now these are the agents. Now what we can do is, if we can take this group, we can sort values by ADR and put it in descending.
Okay.
So you can data in this. Yeah. Right? So that will be basically it's dot sort values.
Dot sort.
Yeah, and then do values.
Values.
And if you open the parentheses, you can do shift tab. If in doubt, just do shift tab.
Yeah.
And just check. So you can see by and ascending is equal to 2. So you have to basically say ascending is equal to false and by you have to say ADR.
Yeah.
Actually it will be small, I think. You can just check.
Yeah, I think, you're right.
Yeah. Great. So let's take a look at what's happening. According to the agent, the ADR.
So this is an interesting thing. This guy, there is no cancellation ever happening. The mean itself is 0.
Always new guest, is it?
I'm sorry?
It's always a new guest.
Yeah, and it's always a new guest. And of course, this will not be a big deal.
That's like
or perhaps this is a very small number. It's like one case, I think. That is also possible. Because we don't know now.
Okay. Then what I would say is,
can we add that somehow?
No, try to do, instead of having a mean, put a count instead.
Yeah, no. So what I say is, for instance, because right now we need the count for the number of agents, right? So can I add, for instance, DF agent?
So you can actually check out. You can check. Now I'll tell you. You can check out this thing called AGG. So you can check out the AGG function aggregate.
For what?
When you want to create a data frame with different columns. So for example, you can group by. So you can just copy that group by statement above.
Okay. Yeah.
And instead of mean, delete the mean.
Okay.
And put AGG. And
AGG?
Yeah, and just open the parenthesis and do Shift Tab.
Yeah, that's not. It's not going.
Oh, so just delete it and see if AGG exists, because maybe it doesn't exist on this. It does exist. So then why is it not coming?
Shift Tab, right?
Yeah.
No.
Ah. Okay. No.
No. It's I just did Tab. Shift Tab, there's nothing is happening. Probably there is no. I'll check.
Okay, just Google then, I guess. Because AGG, from what I know, it helps you to have different functions for different this thing. What do you call it? Aggregating, summarizing, aggregating. Just say group by aggregate. Okay, yeah. Okay.
Yeah,
Add AGG function.
Yeah, this is what I want. Yeah, so we have function to use for aggregating the data.
So you see np.sum, np.mean. So if we have a group by, so the first is if you have a group by, if you just come down, you will see some examples. See here. So now you see the df.ag is sum and min. So it has created two different ones. So here you see it is df.ag is sum axis is equal to columns.
Okay. So I think this is just aggregating and creating a sort of. I mean, first I don't know.
Okay, let's try. I'm just thinking.
No, I will just see. For instance, we'll go back. And then,
so if you say aggregate and within that open a dictionary.
Okay.
And let's try out just two. Let's not complicate. No, just curly braces. Curly braces mean dictionary. Yeah. So here you can just say in ADR, that is in quotes, you put ADR. And here ADR we will say np.mean, colon np.mean. And then comma, you can choose any one other column. It's just, you're just passing a function. You're not calling it, you're passing the function. So this is like a callback. And then put a comma, and then can you scroll up? We'll check the column, which other column we want to do a count. So I would say,
because we don't have the agent column.
Okay, then what I would say is just put this, create a new one called agent count and make it np.sum.
Okay. In this itself?
Yeah, the next one, let's call it agent sum and agent count, yeah, sorry, agent count, and we'll call it np.count, np.sum, sum is also okay. So let's try this and see what it gets. Might give an error, yeah, let's see what it's saying. Why?
Nested renamer is not supported.
Okay, this might need some amount of googling, but okay. So now let's try to break this up. We can do it in another way. What I would say is we can now create two different data frames and aggregate them together, which would be the same thing. So I would say create one group by function with an np.mean, create another group by function with an np.count.
Okay, but okay. Okay, this is here.
Yeah, so it all counts. So now pick out any one, like you can say you can pick out one EDR or something and rename it as agent count. Give it a new thing. So just put open this. Yeah.
Or you can yeah, I see what you mean.
Yeah. So then we'll club the two data frames and we have the data that we want. So we can look at who's what doing what.
So we can agent count is equal to
just pick out DF hotel. Just any one of them is hotel.
Yeah.
It's just that we can use that as it is, but it will be easier to actually make some sense out of it.
Yeah, I see. Now you want to do an aggregation of this and that.
Exactly.
Wait.
So what you can do is now create another data frame, pick out one column from here, one column from there, basically.
But can't you just add this data frame into that?
You can do a join, yeah. You can do a join. Yeah. So, but the only thing is we'll have a lot of these so you can just take the original one, DF agent group, and just create a new one which is called agent count and equate that to this new agent count here.
Yeah, exactly. So yeah, we have an agent count here.
Good. So now let's suppose, for example,
if I do this
same thing, sorting. Okay.
Yeah, you have only two of them. That's why.
So now let's say you sort it according to agent count. Then what happens? So then we are now looking at the agents which book the most.
Yeah, exactly.
So the agent count so supposing you take head of 20 of this. Sorry? Just take that first 20, just say head 20 if you take. So that because we don't need all the ones below. Okay, interesting. So now just thinking. What could we do with this?
So one of the things that we can just say, for instance, we have right now done this weekend's weekday stay. We can put them together first. I mean, this is one thing. Even before that, we can put them together just to see how many days somebody's staying, and then perhaps also check which hotels that they are staying. I think we are not tracking that. Because if one agent is only booking in one type of hotel, that is also another thing, because that way it's changing that. But I don't know what else we can do with.
So I'm just thinking about it, thinking aloud. We have the ADR, we have the agent count, right? So technically speaking, we can calculate how much an agent actually brought in. Because basically the average daily rate is what that agent is responsible for, right?
Yes.
So now the agent, of course there will be differences, but if you take the average and we multiply it with the agent count, this is how much the hotel has got from this particular agent.
Yes.
Right?
Yes.
Now, if you were to do that calculation, so let's say we create another column saying agent revenue, and we multiply the ADR with the agent count, right? And now, let's suppose, for example, we want to now put a cap and say, okay, supposing we calculate it.
Yeah. So I think for that, I think we have to also include the stays in week, number of days also.
Right. So now, with respect to stays in weekend nights, we are still using the average, right? Or no? This is the mean, right?
Yeah. So we'll have to go back and then first we have to probably create one column which is number of days stayed, and then what we have to do is create another column which will be ADR into the number of days stayed for that particular entry, and then we'll need to have a separate column of how much they spent during that stay. and after that we'll have to sum that for each agent. So there is an agent count that we have. So I'll try to do that.
So you mean there is a weekend rate and a weekday rate?
I'm sorry?
Is there a weekend rate and a weekday rate? No, there isn't, right?
I don't know.
Okay. It's just ADR is given.
Yeah, it's just an ADR, so it's difficult to say.
Okay, no problem.
So but we can just say like, I think that will be difficult to find out.
Yeah, no, that's different. That's okay. So now, if you were to take a look, see for example, if you just look at the data here, most of the times we find that actually the weeknights is much more. Most of the cases.
Yeah, but that's obvious, right? We have 7 weeknights compared to 2 weekend nights, so that's going to be obvious.
True, but what this actually points towards is that even though that is the case, most of these are long-term stays. Because if for that to happen, that is for the weekdays to overcome the weeknights, it would mean that these people are actually staying for a week or 2 weeks. If a lot of the trips were weekend trips, then in that case, you would have a lot of weekends and just maybe one day here and there, typically. Like for example, you take a long weekend and you go somewhere, you would just use a Saturday, Sunday and you would add a Friday or a Monday.
Yeah. No, but this will then vary, I think, with respect to whether it's a resort hotel or a city hotel.
That's
because
true.
City hotel, when it has a business travelers, it will be more
during the week. Yeah. Okay.
Yeah, but I think for that we can do. So maybe the question that you asked, we probably figure out just the answer for that.
Yeah.
Like, what is which are the top 10 agents who brought the maximum amount of money?
Yeah.
It's not about how many bookings alone, but also maximum money because they booked a lot.
Right.
So we'll probably can do that. Probably I think so we need a set of columns. I think.
I mean, simply speaking, you can just create a DF agent revenue and multiply DF agent count with ADR. If this is a really huge, I would say create like a column. So it's basically in this, you can take the same thing.
I'm sorry. What I'm going to do is, okay, within the same, let's say,
if it is a very large data frame, very large, and I'm talking about millions and millions of things, it might be better to actually use an apply function and apply it rather than doing it this way. Because when you extract the column.
So the question here is, we want to multiply ADR with the number of days stayed, and then this whole thing, the sum of all this, I think, no, not sum of all this, because we'll have to account for the fact that the agent has brought not the ADR, but actually ADR into the number of days that stayed.
Okay. Yeah. So, like actually speaking, if you really look from a simple perspective, even just that product will give you an idea of what's happening. If you really want to be that's it. If, however, you would like to be more precise, then we can just actually write that apply function, because like you said, let's just write.
We can try the apply function because anyway, it's so we can try. So what do we do with this now is multiply the ADR with the value counts. With the.
So basically, we are going to multiply ADR into first some stay in weekend nights plus weekday nights. Multiply that by the ADR. This gives us like the total stay per person, like typically, and then multiply that by the agent count, which tells you the total revenue an agent brought in.
Yes. So the thing is this. You mean here you want to multiply it by the average stay?
Yeah, I guess for now that's good enough. We can actually do it later.
Because that is why I was confused because of that. Okay, let's compute the agent value.
Because you can repeat this in the actual data frame as well, and then regroup it, and we can check it out.
Because in that case it's a bit different, but anyway. So this is like you take
basically always X. So that's the thing. So since we are now dealing with several columns, we have to use what is called as the access method. So first assume that this is like access X is as it is. So all you have to say is you have to assume that this X is like one row of a data frame, because the apply command is used on every row of the data frame. So now you must return assuming this way. So you can just do that calculation itself. So you can just actually just return.
Yeah, okay. So return
and the calculation. So basically it will be X into stay in weekend nights. X, not X. X square brackets. Okay. Yeah. I'm assuming you're going to sum it.
Yeah.
I think that will be the other one. And then finally multiply this with the agent count.
Right.
Well, I would suppose that is not sorry? Because it's multiplication and you don't need another bracket, but it's okay.
Yeah,
okay.
I think
that's okay. It's okay. X. Only thing you have to specify X. And also close it. So now what you have to do is you need to apply it. So what we do, the way it works is like you can talk about the agent group. Now you say dot apply as always, and always you can do shift tab to check out what it is, and I'll tell you what that means. So you see the first one is the function, right? That's the first argument which is necessary. The other one is the axis. Now axis typically means is equal to 0 means rows. So when you apply any function, if you do not specify the axis, it will only go along the rows. So it actually assumes that it's a series, because it assumes that for every row there is only one value, which is the case of a series. But in our case, we have to tell the apply function that before you start going for each row, within a row you need to start looking in the columns as well. And that is what the axis command says. So axis means you have to use the columns of the data frame and then iterate with each row. So here you have to specify the first argument is the function, and second you have to say axis is equal to 1. So you can, if you can leave it, let's say axis equal to 0, and you see the error will come. You can check out the error because there are. So if you see here, if you go all the way to the bottom, you'll see that key error address. So what that means is it is saying I don't know what this key error is, right? Because it's actually expecting a series. It's expecting a single value. So now if you say 1 and you do it, now you get back this. So you can now assign this to another column, and that becomes a new column in your data frame. So that's it. So this is actually interesting because now you see these are actually bringing in millions and hundreds of thousands. Single video.
Now I'll sort it.
Yeah. Ascending is equal to false. Sort values.
Sort.
Yeah. Oh wow.
So
that's actually impressive. So this shows that actually these agents are indeed playing a fairly large role. This thing.
Yeah.
And if you look at the tail instead of the head, so what I'm saying is, like for example, if you look at the tail, it'll be interesting to know how many of them are just ones.
Yeah, many of these are just ones.
Just ones. So really speaking, these are people, actually they may not even be agents. They may actually be people who are just booking for themselves just once, but they are still called as agent.
Yeah, I see. Yeah, perhaps that looks like.
Yeah.
But anyway, that is not necessarily also very easy to say, because 333 agents for 120,000 booking, no, not necessarily.
Yeah, you never know. Maybe somebody.
Yeah. So, but there are some things like interesting things like there are 32 counts, but the total value this guy has brought in just this. So,
most of them look like cancelled because you see the ADR is nothing. So it looks like he had a huge number of cancellations.
Yeah, exactly. That's what has happened.
Yeah.
So here, maybe we'll have to have a better, different numbers for these, I guess. Is cancelled, I think we'll probably have to have a different type of number.
Exactly.
Can we do that? Like, for instance, in this case, for instance, this group, I would prefer not mean values, but the counts. Like, for instance, is cancelled, the number of times it was cancelled.
Mm-hmm.
And that's why, for instance, this one is clear. Like 30, there's one cancellation, and that's why you see that there is the total agent value is 30. This is ADR is 30. Most likely, it's the cancellation fee.
Yeah.
So yeah, I mean, I don't know. Maybe how do we do that? Like, for instance, I want to change. I want to bring here, for instance, we did a mean for everything together.
Mm-hmm.
I think so here we did a mean. Okay, maybe we'll have to do quick count from here and bring it probably. Perhaps.
I would say that count in that case won't be much, because for every cancellation, maybe it's like 1 or 0. So if you have like a huge number of if you have cancellations, it just is a larger number if you count it.
Yeah. I'm sorry. No. I think it will be the same. I'm sorry. What I just want is the number of times. Say, look, here it says that 0.1562.
You can actually do a sum, because a sum means the total number of times that he got cancelled.
Yeah. It should be a sum. Yeah, right. Rather, it should be a sum.
Yeah, you can guess.
Maybe we'll have to do a sum. This thing like here we did instead of count, we'll probably do a sum and then add that as the column instead of whatever is existing.
Yeah.
Perhaps. So we'll see sum group agent. Okay, sum, and then I will take, for instance, I think both is cancelled. Yeah, I mean, I think for everyone, let me just see what. So, yeah, I mean, you can see that the number of this is actually a lot more interesting to see. Is repeated guest is like 187 and all that. I think all of these three columns is cancelled, is repeated guests, and perhaps the stays in week A and weekends. All of these we can put here with these values. So maybe it's useful, right?
Yeah. So I would say I think we should conclude now because it's already like 7 p.m. So I think we should.
Oh, is it? Oh, okay, I didn't see that. Okay.
Yeah. So I think, yeah. So I would say that go ahead. I mean, with this thing, maybe next time we can actually talk about whether we want to do something else or whether we can take on the next challenge with this.
Yeah, we can also even try some other type of data if you want.
Yeah.
Maybe somebody else is there, because this is one type of data we took. Maybe
Yeah.
if you want.
Yeah, pick out. That's always good. You can always pick out another data set.
Yeah, exactly. Because this one is tabular data. Maybe we can look at some other type of
Yeah.
if you want.
Yeah, sure.
I mean, I don't know. Tabular data is what is easier to do EDA, exploratory data analysis, because others I think it's not that easy.
Yeah. This is the CSV files are usually the best, and that too, if they're numerical values more, it's usually easier to handle them in the beginning. So that is all.
True. We'll probably look at some time series data.
Okay, will do.
Okay then.
Okay, sure then. Okay. See you next week.
Yeah.
Okay then. Bye bye.